they're having a mass m. Now look at this. What are the forces is asking reaction change. So shall we directly go for this? Mg. The reaction I'll just show on the rod in this direction. And the tension, the string, let it be like this. The system is in equilibrium. So therefore the net torque on the rod should be 0. And the net force on system along x and along y axis should be 0. So from this, T minus Rx minus T is equal to 0. And then Ry minus Mg equal to 0. So I got Ry equal to Mg. Then what are unknown things? Rx and T. So what are unknown things? Rx, Ry and T. 3 unknowns are there. We have one equation. So let me go for one more equation. I'll go for torque acting on the rod about axis passing through and perpendicular to plane. Mg into, so this angle is theta. Okay, it is given. No? I try to see this Mg. This distance is c, no? So shall we go for L by 2 cos theta? If this is theta, this is L by 2, how much this distance will be? L by 2 cos theta. Then Mg will act here. Then what is the torque? L by 2 cos theta into Mg, and it will be clockwise. Torque due to Rx, reaction Rx will be 0. Torque due to reaction will be 0. Let me put that also. Then torque due to tension, T into, what about this distance? L sine theta. Since it will be like this. So what is the state of the rod in equilibrium? Should be 0. So Mg L by 2 cos theta. This will be 0. Why Rx and Ry? Torque due to Rx and Ry are 0? Because they will intersect axis of rotation. Plus this is TL sine theta. So therefore what is the tension should be equal to Mg cot theta by 2. So now you got the tension, substitute here. So then you can calculate the total reaction. Rx square plus Ry square. This reaction, the reaction by ohm, what is R? R is not radius. Reaction at inch. By the inch on the rod or by the rod on the inch? By the, say I'm showing the forces here. On the rod I'm showing. On the inch it will be like this. The inch will push the rod up. In turn, the rod will push the inch downward. Now you should be very careful. Just make good observation, nothing big.